Imagine farming without soil, without traditional watering, just mist. What if the future of agriculture looked like clouds feeding crops? This isn't science fiction, it's a revolutionary method that could redefine how we grow our food. Welcome to the Fields of Innovation YouTube channel. Smart farming starts here. Discover the future of agriculture, where we share information about technology applied in agriculture. Today, we're diving deep into Fogponics, an advanced form of aeroponics where plant roots are suspended in the air and fed through an ultrafine nutrient-rich mist. This technology isn't just a niche experiment, it's becoming a critical solution in the face of modern challenges. With climate change shrinking arable land and creating unpredictable weather, and water scarcity demanding more efficient irrigation, we need new ways to grow. Add to that the explosive growth of urban farming, which requires compact high-yield systems to feed city populations. In this video, you'll gain a complete understanding of Fogponics, from the science behind it to its global applications and its incredible potential for the future of food. So, what exactly is Fogponics? To understand it, let's compare it to its predecessors. In hydroponics, plant roots are submerged in a nutrient-rich water solution. Aeroponics takes this a step further by suspending the roots in the air and spraying them with a nutrient mist. Fogponics refines this concept even more. Instead of a spray, it uses a true fog, where the nutrient particles are micron-sized. This is the key difference. While aeroponic droplets are larger, the tiny particles in a fogponic system provide an unparalleled level of nutrient absorption. The smaller the droplet, the more surface area it can cover on the intricate network of root hairs, leading to more efficient uptake. The magic behind creating this fog lies in ultrasonic foggers. These devices use a ceramic diaphragm that vibrates at ultrasonic frequencies, atomizing water and nutrients into a cool, dense vapor with droplets measuring just 1 to 10 microns in size. To visualize the difference, imagine a garden hose sprayer versus a morning fog rolling through a valley. The sprayer drenches surfaces with large droplets, while the fog gently blankets everything with microscopic moisture. The science of absorption is fascinating. When nutrient droplets are this tiny, they can penetrate deeper into the root hairs and maximize surface contact. This means plants can absorb nutrients almost instantaneously, without expending energy growing long root systems to search for them. The result is accelerated plant growth and significantly higher nutrient uptake efficiency. The journey to Fogponics didn't happen overnight. Its roots can be traced back to early aeroponics experiments throughout the 20th century, particularly from the 1950s to the 1980s, where researchers first began spraying nutrient mists onto airborne plant roots. As these studies progressed, a crucial discovery was made. The finer the mist droplets, the more efficiently the plants absorb the nutrients. This realization paved the way for the evolution toward Fogponics. A major catalyst in this development was NASA. In their quest to find sustainable ways to grow food for astronauts on long-duration space missions, where soil is impractical and resources are extremely limited, NASA began testing Fogponics. Their research was groundbreaking, with studies showing that Fogponics could reduce water usage by as much as 90% compared to traditional soil-based farming. This made it a prime candidate for life support systems in space. Back on Earth, university research in countries like Canada, the United States, and across Europe has continued to validate its potential, proving that Fogponics can successfully grow a wide variety of crops, from leafy greens and herbs to even fruiting plants like strawberries and tomatoes. The benefits of Fogponics are what make it such a compelling technology for the future. First and foremost is its incredible resource efficiency. By delivering nutrients in a fine mist, the system uses significantly less water than any traditional irrigation method, and even less than hydroponics or standard air. Every drop of water is utilized, and nutrients are delivered with such precision that waste is virtually eliminated. This efficiency translates directly into faster growth rates. Studies have shown that plants grown in Fogponic systems can grow 20 to 30% faster than those in soil or hydroponics. This is because the roots are constantly bathed in readily available nutrients, allowing the plant to redirect its energy from root growth to foliage and fruit production. Space efficiency is another major advantage. Fogponic systems are perfectly suited for vertical farms and urban agriculture. Because they don't require soil and can be stacked vertically, they can transform warehouses, basements, or even shipping containers into highly productive indoor farms. This allows for food production directly within cities, reducing transportation costs and carbon emissions. Furthermore, Fogponics offers cleaner and safer crops. Growing in a sterile, enclosed environment means minimal exposure to soil-borne pests and diseases. This drastically reduces, and in many cases completely eliminates, the need for chemical pesticides, resulting in healthier produce for consumers. Finally, the technology is highly scalable. It can be implemented in a small DIY setup for a home grower or scaled up to a massive commercial operation capable of feeding thousands. However, despite its immense potential, Fogponics is not without its limitations and challenges. The primary barrier to entry is the high initial cost of setup. High-quality, ultrasonic foggers, environmental control systems, and sensors are expensive compared to more traditional farming equipment. The nutrient solutions also require precise balancing and monitoring to ensure the plants receive everything they need. Maintenance can also be an issue. The ultrasonic diaphragms and foggers can clog with mineral salts from the nutrient solution or degrade over time, requiring regular cleaning or replacement. Maintaining a consistent droplet size is crucial. If the fogger malfunctions and produces larger droplets, the system's efficiency plummets, essentially reverting it to a less effective aeroponic setup. Another significant challenge is its dependency on a reliable power source. The foggers and control systems require a constant supply of electricity. This makes fogponic farms vulnerable in regions with unstable power grids or during power outages, where a system failure could quickly lead to crop loss. There's also a knowledge barrier. Managing a sophisticated fogponic system requires a different skill set than traditional farming. Farmers and technicians need training in plant science, nutrient management, and engineering to operate these advanced systems effectively. Lastly, while the science is sound, there is still a need for more long-term, large-scale case studies. Compared to hydroponics, which has a decades-long track record in commercial agriculture, Fogponics is still a relatively new frontier, and more data is needed to prove its long-term viability and profitability at a massive scale. Despite these challenges, Fogponics is already being applied in innovative ways around the world. In North America, particularly the US and Canada, commercial indoor farms are using Fogponics to grow high-value crops like lettuce, herbs, and microgreens for local markets. These operations are often backed by tech startups and university research programs dedicated to advancing controlled environment agriculture. In the UK and Australia, Fogponics is being integrated into national strategies for smart agriculture and sustainable food security. Government-supported projects are exploring its potential to create resilient food systems that are less dependent on imports and less vulnerable to climate change. The technology is also seen as a powerful solution for farming in extreme environments. In desert regions like the Middle East or parts of Africa with limited freshwater, the water-saving nature of Fogponics makes it a game-changer. Similarly, it's being used to create sky gardens and high-rise farms in dense urban centers, bringing food production closer to consumers. And, of course, NASA continues its research, viewing Fogponics as one of the most promising candidates for sustaining human life on long-term missions to the Moon, Mars, and beyond. It represents a pathway to self-sufficiency for future space colonists. Looking ahead, the future of Fogponics is incredibly exciting, especially with its integration with other cutting-edge technologies. The next wave of Fogponic systems will incorporate AI and the Internet of Things (IoT). A network of sensors will monitor humidity, temperature, nutrient density, and even droplet size in real time. This data will be fed to an AI-driven control system that can automatically adjust conditions for optimal plant growth, creating a truly precision farming environment. To address the challenge of power dependency, we're seeing the development of solar-powered Fogponic systems. This would not only reduce operational costs but also enable off-grid farming in remote or disaster-affected areas, providing a resilient source of fresh food where it's needed most. Ultimately, Fogponics has the potential to play a significant role in achieving global food security. As the world's population is projected to exceed 9 billion by 2050, we need innovative methods to produce more food with fewer resources. Fogponics offers a way to combat hunger in regions with poor soil conditions or water scarcity, turning non-arable land into productive agricultural space. The future outlook is bright. If the costs of the technology continue to decrease and the systems become more user-friendly, Fogponics could become as mainstream in the next decade as hydroponics is today. In summary, Fogponics represents a monumental leap forward in agricultural technology. We've seen its remarkable benefits in efficiency, speed, scalability, and sustainability. When compared to traditional farming, the differences are stark. It uses a fraction of the water and land while producing higher yields of cleaner crops. It moves farming from the field into a controlled, optimized environment. Fogponics might not just change farming, it could change the way humanity produces food on Earth and beyond, ensuring a healthier and more sustainable future for generations to come. What are your thoughts on Fogponics? Can you see it becoming a major part of our food system? Let us know in the comments below. We'd love to hear from you. Don't forget to like, share, and subscribe for more deep dives into the future of agricultural technology.